to Miles and Dash's POW 12. Today's POW is the mouse. City Hall in Columbus, Ohio has a splendid rectangular lobby with a floor of black and white tiles. The tiles are square and a checkerboard pattern, lined up with the walls, 93 tiles in one direction and 231 in the other. Now, in this particular lobby, there are two mouse holes at diagonally opposite corners of the floor. One night, a mouse comes running out of the mouse hole and runs fast straight across the floor into the other mouse hole. Question number 1. How many tiles does the mouse run across? So, the answer for question number 1 is just a straight answer because the explanation comes in the next question. So the answer for question number 1 is 323 tiles. So now Dash will explain number 2.
Yes, I will.
That's the area. How many squares is it?
Let's go number 2. So, question number 2 is, what strategy will you use to begin to solve this problem? Describe your strategy in detail. So for this particular problem, we actually, number 1 was the answer. It should have been number 7, but we gave the answer at first, so just bear with us. And number 2.
So number 2 is we use the strategy of finding a pattern, and in this case, finding a pattern within other patterns, because there were a lot of other things that we needed to use because it wasn't always the same pattern. There were a bunch of different patterns for each, so we needed to find a pattern within a pattern.
So for this particular problem, we solved a simpler problem and found a pattern within that simpler problem. So for question number 3, the question is, for question number 3, the question is, what pattern did you find in your data? So at first, we tried finding patterns in the number of tiles across of smaller rectangles, such as a 1x2 rectangle, or a 1x3 rectangle, a 1x4 rectangle, or a 2x2 rectangle, a 2x3 rectangle, a 2x4 rectangle, or a 3x1 rectangle,
We said that too.
3x2, actually forget 3x1, 3x2, 3x3,
All the numbers in that
3x4,
or in that square.
3x5,
Oh, and then 3 or 5
3 by 6,
10, and then 5 by 7, 11.
3 by
So
7,
for all the those,
3
it
by
goes up
8,
by 1. But
etc.
the ones where it's divisible.
So, for the ones,
goes up.
we added them up together. So 1 plus
But
2
not, like,
would equal
2 by
2.
4 is 4, and then 2 by
1
5
plus
is
3.
6, and 2 by
Oh, sorry. So for these,
2 by 6 is
the number of tiles across
4 by
would be
8. And it
2.
goes- so it goes up by
Numbers of
2.
tiles
But
across
then-
for 1 by 3 would be 3.
Yeah.
And 1 by 4 would be 4. Which means that it would basically be
4 by 5 is 8.
half of the perimeter of the object divided by 2. So
I lost my train.
just the two sides,
Okay.
1 and 2,
So we were saying
added up together, which
2 by
would be 3, minus 1 would be 2.
triangles or rectangles with like 2
Now,
by
this is
4,
just
2
for
by
this
6,
one,
2 by
so.
8, all the
For number 2, for pattern 2, we found that 2 by 2
Did you say something about it
would
going
make
up to
2.
Yeah.
2 by 3
So
would
2
make
by 4
4.
is 4.
2 by 4 would make 4. 2 by 5 would
And
make 6.
2 by
2 by 6 would also make 6.
2 by 4.
So in the sequence
and
that we have right here,
6 is
the
6,
pattern
and
would be
2 by
x
8
plus y minus 1,
So it goes up
and then
by
for the
2.
next one,
It goes into all of them, and the width increases by 2, so it goes up by
so it'd be going like 2, 2, 4, 4, 6, 6, 8, 8, etc.
Okay, and then
So the pattern would be
3 by
x plus y
3 by 4
minus
is
1.
6.
The next one would be x
And 4
plus
by
y minus 2.
I did
So
all
for
of
number
them
3,
7. So 4 by 4
3 by 1 would be 3.
And so then 4 by 8.
3 by 2 would
which I
be
did
4.
do, would be 8.
3 by 3 would be 3.
Prove it.
3 by 4 would be 6.
Because of my equation.
3 by 5
which
would
I
be
know is
7.
correct, because I just-
3 by 6
which I was
would be
brought
6.
up proving. So when it goes
3 by
up
7
like that,
would be 9. And 3 by 8 would be 10. So in this particular sequence, it would be
but
x
the width
plus
increases
y
by,
minus
that's
1.
how many
The
tiles
next
it
one in the
increases
pattern
by.
would be
When
x
it's like-
plus y minus 1. The third one would be x plus y
Do you wanna
minus
say something
3.
about the factors?
So, now we found out, we realized the real pattern.
And
The pattern
four-
was
so when we
between
do
the
2
patterns.
by 4,
every number of tiles
2
crossed
into
was the
4
was the sides of the rectangle
goes
minus 1, or in the case of a special rectangle, going up by x, every multiple of xy is. It will be x plus y minus x. So in the 3 sequence, the third one would be 3 plus 3
That works.
minus 3.
One less.
The sixth one would be 3 plus 6
That's the way.
minus 3, which would be 6. And then 3 by 9 would just be 9.
So you're
3
saying-
plus
oh.
9 minus 3. So this was the pattern that we found. So using this pattern, our conjecture was, our conjecture, just reminding you guys,
From our last video.
from our last video of PAL 11,
Click here.
flashback!
Click here to look back.
Click
at a-
here for PAL 11. Click right here. Click here.
Okay, you're numbering
Yeah.
tiles.
It's
This
an
is
actual
actually
thing where you can click it, and that hurt a lot. Okay,
off. That should
going
be-
back to PAL 11, flashback. So conjecture is an idea that you have not proven.
Number 3.
Unflashback. So now you know what a conjecture is. Dash.
Yeah. Our conjecture was, for every number of tiles crossed, it will be 2 sides of the rectangle added together, minus 1, or in the case of the first side being a multiple of the second side, the number of tiles would be the same as the second side.
You don't think so?
Yeah, that was our conjecture.
Okay.
So, for number 5, the question was, for number 5, the question was, how can you use your conjectures to show that your answer is
How
correct?
many does it go by?
So there is a difference between showing and explaining. Showing is when you use a picture, a graph, a diagram. So in this case, we are going to show you how this works.
And we're also going to explain it because we're making a video.
Yes. So, our conjecture in math form is this: x plus y minus 1, or in the special case that we had just discussed, x plus y minus x. So, this would mean that, to use our conjecture here, it would be 231 plus 93, which would equal 324, minus 1, which would equal 323, which would be our answer. Question number 6 is, why does your answer make sense? Go!
Our answer makes sense because it works just like all the number of tiles works by our conjecture.